We have one more asset to complete before we can build the low-level logic that will oversee the game, and that is our dartboard. Let's start this video in the map C4 game stage. We're going to create the dartboard so that when hit, it will give us an amount of points. There are two types of points we can get. The first will be a standard point, which is when we generally hit the dartboard. The second will be a bonus point, which occurs when we hit the randomly chosen bonus quadrant. For now, we'll create this to simply print our score to the screen, and later we'll use this data to update a 3D UI widget. Let's start by creating the dartboard mesh. Right-click in the content browser in the dev folder and create a new actor blueprint named BP Dartboard and open it. Add a cylinder to the component list named dartboard and set its rotation to -90, 0, 0. Also set the scale to 0.5, 0.5, 0.1. Add an arrow component to the root and rotate it to match the dartboard. Select the dartboard and change the material to M dartboard. Lastly, add another static mesh named backboard. Set the static mesh to SM monitors horizontal bezels 16 by 9. Set its location to 0, 6.5, 0, and the rotation to 0, 0, 180, and the scale to 0.8, 1, 0.8. Lastly, change the material in element 0 to M black background. Okay, it appears I've rotated my arrow in the wrong direction. So I'm gonna flip it 180 degrees so it's pointing out forward. And compile. Okay, let's dive in. From the event begin play, drag in a reference to the dartboard and search for create dynamic material instance and promote the return value to a variable. This is so we can alter parameters that have been made inside of the M dartboard bonus material. These parameters are just to display the quadrant that the dartboard has chosen as the bonus. While we will be creating the logic to choose our bonus quadrant, we will only implement the material change when we are working with UI. Return to BP dartboard and create a custom event named dartboard hit. And add an input of type vector and name it hit location, and another of type primitive component named component hit. From the event, drag from component hit and search for an equals node. Plug in our dartboard and connect this to a branch. For now, add a print screen node to true and write dartboard hit in the string, and one to false as well, printing backboard hit. Just to help me differentiate the two, I'm going to change the color of dartboard hit to an orange, and leave this up for a bit longer. We'll set the rest of this up shortly, but first let's place the dartboard into the map. I need to remember to set that backboard to the scale that we needed it to be. So it's 0.8, 1.8, and I'll compile this. Now we'll drag it into the map, select the original screen that's here, and copy the location, and we could delete it. Now paste the location into our BP dartboard, and we may need to make some alterations just to get it to the right position. And I'll save. Open BP Dart. We need to set up some logic to determine if what was hit was just a surface or the dartboard itself. After the branch in the check if hit something function, move the call to stop dart motion over. We'll check what the dart hit here. Expand the break hit result and from the hit actor cast to BP dartboard. Plug this into the true. From the as BP dartboard, call our dartboard hit event. Plug the hit location into the impact point and the component hit into the hit component. Plug back in the stop dart motion event after dartboard hit. Let's press play in VR and test this. So I'm just going to throw it, and I'm going to be aiming for the backboard hit. And I'm going to be aiming directly for the dartboard itself. Dartboard hit. I think we originally made that float value that the align trace is searching too low. Let's increase that a bit. From 5, let's make it 10. And try once more. There we go. We'll now write a function that uses a bit of geometry to determine which quadrant our hit was in. This isn't as complicated as it might initially sound. For now, we're going to just assume the bonus quadrant is 1. In the next video, we'll be setting up the function to determine the actual bonus quadrant. But right now, back in BP dartboard, create a new function called determine quadrant of hit. Give it one input of type vector named hit location and one output of type integer named quadrant. And compile. And to continue keeping things organized, I'm going to place this in the hit quadrant category. We're going to move the return node out of the way, but we will need a few of them shortly. Split the hit location struct. From X, create a new vector 2D node. Plug Z into the Y. We are searching on a 2D plane, so we don't care about the Y, as that would provide the depth in this setup. Drag a reference of the arrow and get its world location. Again, make a vector 2D the same way as before with the X and Z. Subtract the arrow's vector 2D by the hit location's vector 2D. Split the result struct. Right-click and search for a tan 2 degrees node. And plug it directly in as such. Briefly, this will give us a counterclockwise angle in degrees from -180 to 180. Starting at the top of this 2D circle is -180 degrees, and increases as you move more counterclockwise to eventually be at +180 at the top again. Let's make this a bit easier to understand by adding 180 to the result. This would make it a range of 0 to 360, which is more familiar. Promote this value to a variable. Now, remember your quadrants of a circle from geometry. On an imaginary two-dimensional plane, positive x and positive y, or quadrant 1, is located in the top right. Negative x and positive y, or quadrant 2, is in the top left. Negative x and negative y, quadrant 3, in the bottom left, and positive x, negative y, quadrant 4, is in the bottom right. What we are doing here is not detecting the hit of the dartboard, but comparing the hit of the dart to the arrow's location and based on the angle between the two, deciding which quadrant it is in. Use this logic to create as many segments of the circle as you'd like. For reference, a standard dartboard has 20 segments with 18 degrees for each one. We need to now compare the local result variable to a float value. Right-click in the function and search for compare float. This is simply a small macro provided by Unreal Engine. If you'd like to see how it's built, double-click it. Plug the result into the input and compare the result local with 90. As in, how does the input compare with 90? Is it greater than, equal to, or less than? If less than 90, it must be at the top left, which would make it quadrant 2. Drag from the less than and simply type a period and select return node. Type 2 into the quadrant output. From greater than and equal to, create another compare float, but now compare it with 180. And if it is less than 180, it is at the bottom left, making it quadrant 3. Repeat one more time, and this time compare with 270. If it's less than 270, it is at the bottom right, so that makes it quadrant 4. Now if it's greater than or equal to 270, that makes it quadrant 1. Now compile. We only want to call this if we actually hit the dartboard. So in the event graph, after the branch node, plug this function into true. This way it only gets called if you do hit the dartboard. And plug hit location into the input of hit location. From the returned quadrant, drag out and search for an equal to node. Type any integer from 1 to 4. I'll write 3. When we hit the bottom left of the board, or quadrant 3, we want it to print to the screen that we hit the bonus. So we'll create a branch, and from true, we're going to create another print string. And I'm going to write bonus hit. And I'm going to keep this up a little bit longer so I can see it. Press play in VR and try to hit the quadrant you chose. So I chose quadrant 3, so I will be trying to hit it at the bottom left. Bonus hit, first try. And there we have it, bonus point. Next, we'll set up the remaining mechanics for our dart game.